In lesson 7.4, we're going to learn how to use the trigonometric equations that we learned in 7.3 to solve for missing angles instead of solving for missing sides. So we're still using the same three equations, but this time our variable will be where the angle is instead of where the sides are. So remember, the sides are always in the fraction and the angle is always next to the trig word. So our variable will be in the spot where the angle is. So if you look down to example 1, those 4 different triangles, there are no angles labeled on the inside. They all have a question mark. So we're going to have a variable where the angle is. So if the variable is where the angle is, how are we going to isolate the variable? Because the variable has to be by itself. That's how we solve equations. We isolate the variable. So remember how that works with actually any equation. You use what are called inverse operations. So we've already talked about how adding and subtracting are inverse operations, multiplying and dividing are inverse operations, squaring and square rooting are inverse operations. So let's look at that one for a minute. Remember when we did the Pythagorean theorem, we said if x squared equaled 10, to solve that, we would square root both sides. That would eliminate the squaring on the side with the x. Those two inverse operations would cancel each other. So it's the same thing with sine. We need an inverse operation that will cancel it. I know this will look weird, but the inverse operation of sine is sine with a little -1. The inverse operation of cosine is cosine with a little -1. And tangent, obviously, then is tangent with a little -1. So when you put an inverse operation next to a regular operation, they cancel each other out. So over here in these equations, if we just put the word sine -1, the inverse operation, these two cancel each other out. But what you do to one side, you must do to the other. So I would have to inverse the other side too. So the equations end up looking like what we have in the box. The angle when it's isolated is equal to not sine of the fraction of the angles, but sine inverse of the fraction of the angles. Another way some teachers teach it is to think of that trig word kind of jumping over to the other side. When something crosses an equal sign, it has to do it with the opposite operation. So again, let's look at an equation here. Maybe something like 2x plus 5 equals 10. To make this 5 disappear, make it really move to the other side, we use the minus operation, right? We use the inverse operation. So that is another way of thinking about it, is when things cross over the equal sign, they become the inverse of what they are. So a plus becomes a minus, a squaring becomes a square root, and in this case, a cosine becomes a cosine inverse. A tangent becomes a tangent inverse. So those new equations are in the box. That's the equations we can use. So if we look at example 1, we are missing an angle, so we're going to put an X on that. Notice how we only have one variable we're solving for. And we'll talk about why once we finish problem number 1. We have only 2 sides labeled. So we're going to say, well, which ones are they? Are they the opposite leg, the adjacent leg, or the hypotenuse? So the side that does not have a label on it, in this case, it would be this hypotenuse, does not have a label on it. Then we're not going to put a capital letter on it because obviously if it doesn't have a label, it's not necessary to this problem. So we're only going to label the 2 numbers that are already on this triangle. So those are both legs. The 12 is farther away from the X, so that's your opposite leg. The 28 is right next to the X, so that's your adjacent leg. So this is a tangent problem, right? This, if we went back up to the original problems or equations that we're used to, we would use tangent. But if we want to use it as what's in the box to help us solve the missing angle, we would think again of that tangent word jumping over to the other side. So this is just personal preference here. Do you want to start with the tangent word, put the missing angle, which is X, next to it, and set it equal to opposite over adjacent, like you were used to doing in section 7.3? Or do you want to just start with the variable, realizing that the tangent word has to go to the other side is tangent inverse, and then put 12 over 28. So in my class, it's okay to start either way. I don't care if you start with the original equation that I just starred or if you start with the new equation that we have in the boxes up above. So either way is okay. But on any quiz or test, I'm going to ask you to always show your trigonometric equation. So you have to write one of these two equations. All right, so the question now just becomes, how do we get in our calculator that little -1? So you are going to hit the second button and then the tangent button. So if you hit the second button, then the tangent button, then the little -1 should show up. So you're punching in your calculator second, tangent, and then 12 divided by 28. If you do that correctly, your x will be approximately, now you can state it as 23.2, but if you notice the directions, it says to the nearest degree. That actually means they want it to the nearest whole number. So 23 degrees would be what the directions are telling us to say. If you write it as 23.2, rounding to the nearest tenth, like you're used to doing from the last section, that's also okay. But I'm going to round them all to the nearest whole number like the directions tell me. All right, so why are we not using trig again to solve for the other missing angle? Well, if you remember, triangles always add to 180 inside. So if I already know that the missing question mark is 23 degrees, I could just subtract 90 and 23 from 180, and I could get my missing angle that way, and it would be 67 degrees. So usually we end up using trig once to solve for the missing angle, and then we just use the fact that the angles add to 180 to get the second angle. So on tonight's homework, I'm not asking you to get that second angle. It's something we'll be doing at the end of the chapter. For right now, I'm just asking you to solve for the one missing angle that has the question mark on it. All right, so let's just do it a couple more times. This is usually a lot easier than solving for missing sides. So on your picture, first I always just convert my question marks to x's. So I'm just going to convert that to an x. Label what they've given you. They've given you the 20, which is opposite the right angle, so that's the hypotenuse. And they've given you the leg that is closer to the x, so that is the adjacent leg. Now, in most of my answer keys, you'll notice I just start with, hey, my missing angle is equal to, and I know when I'm missing an angle, my trig word has to have the little -1 on it. So again, you can picture it starting on this side and moving over, or you can literally write it out originally as you did in section 7.3. But I usually just start with the x, set it equal to cosine inverse of adjacent over hypotenuse. Whatever you do, you have to give me a trig equation. That's my trig equation when I use one of my trig words. All right, if you put this in your calculator and round to the nearest degree, you're going to get about 66 degrees. All right, in the next one, your missing variable, your question mark gets turned into a variable. The side opposite the right angle is your hypotenuse. The leg that is farther away from the x is labeled with the 33, so that's your opposite leg. This is a sine problem. So you have a choice. You can start as sine of x equals 33 over 57, and then in the next step, move the sign and make it the inverse on the other side, or you can just start that way. So either one of these two equations I've written can be your starting point. So either write this or this as your trig equation. In your calculator, hit the second button, then the sine button. That'll give you the little inverse operation, and round to the nearest whole number. So you'll get about 35 degrees for the angle that is missing in problem C. All right, again, a lot easier than the previous section. So the last one I'm going to do, D, we're going to give that question mark an X. The side opposite the 90 is my hypotenuse. The leg that is closer to the X has been labeled, so that's my adjacent. This is a cosine inverse problem then. So you can start with X equals cosine inverse of adjacent over hypotenuse and put that in your calculator. Or I know I'm kind of being repetitive here, but you could also start with cosine X equals 13 over 29 And then in the next step, to isolate the x, realize the cosine has to move to the other side as an inverse. All right, so in your calculator, hit second cosine, 13 divided by 29, and your missing x is about 63 degrees. All right, so that's how we solve for a missing angle using trig.